Hi, this is Thane Lalulet. This is my final project presentation for CSCI-E 104 Advanced Deep Learning at Harvard Extension School, Spring 2026. My top project topic is AI research assistant with RAG. Nowadays, there's an overwhelming volume of research document on the internet. It is becoming increasingly difficult for researchers to locate accurate information, understand relevant context to complete the task. Traditional keyword-based search systems often return large amounts of result that require significant manual reading and interpretation. This create major challenges for researchers. Uh, although large language models can generate good quality responses, they rely mainly on information learned during training. There are limitations when these models are used in specialized domain without internal or up-to-date information. Some important limitations include no access to private or updated document, weak retrieval capability, lack of citation. To address this limitation, there's a need for an AI research assistant with RAG. This project follow the step below. Baseline AI with lag from CSCI-E 104 Lab 10, Harvard Extension School, improvement 1, PDF document ingestion, improvement 2, metadata filtering, improvement 3, answer citation rendering, improvement 4, re-ranking, improvement 5, streaming responses. Improvement 6, structure JSON output. Improvement 7, external vector databases. And followed by conclusion and reference. Baseline AI with RAG from Lab 10. It already include a lot of basic RAG implementation, such as ingest documents, chunk documents, generate embedding, store vector locally, retrieve top K chunks, answer question with grounded prompt. And this is a architecture of the RAG. Improvement 1, PDF document ingestion. The original implementation used hard-coded text as a data for RAG. It doesn't reflect the real-life scenario that most data are kept in PDF or text file. So adding this capability will allow user to upload PDF file for processing. Improvement to metadata filtering. Metadata filtering is important because it allows document retrieval to be constrained using structured information. As a result, the system can retrieve information with more context. Benefit of metadata filtering. First, improve retrieval precision. So without metadata filtering, the retrieval can include irrelevant information. It's also enable advanced search features, and it's like finally it's improve the retrieval efficiency because filtering reduce the number of chunks to be searched. This is an example of metadata filtering. In this example, I use the doc ID and page number, uh, and the retrieval result just include only this doc ID and page number. Improvement 3, answer citation rendering. Answer citation rendering is another important feature because it allows generated response to include references to the source document. Benefits like improve transparency because the responses include a citation that show the document page or chunk. Um, It also includes user trust because users are more likely to trust responses with supporting references. Finally, it's enable verification and validation. So citation allow user to inspect the original source. This is an example of answer citation rendering. You can see at the end of the response, there's the citation there, and at the bottom, there are references. Improvement for re-ranking. Re-ranking is important because it improve the quality and relevance of the retrieved document chunks before they are sent to a language model. Benefits are improve retrieval accuracy. Initial vector search may retrieve chunks that are loosely related to the query. Re-ranking evaluates the retrieved chunk more carefully and prioritize the chunk that best answer the query. It also improves answer quality. The quality of the response depends on the quality of the retrieved context. As a result, the responses become more accurate. Improvement 5, streaming responses. With streaming responses, users do not need to wait for entire response to finish before it starts to show the output. The output can be displayed line by line as it's being generated. Benefits are improve user experience. Streaming response make it feel faster. User can immediately see the answer. It's also reduce perceived latency. Long answer can take a minute or longer for LLM to finish generating. Streaming responses can reduce it significantly. This is like an example. So you can see that it doesn't need to wait for the complete answer to finish. It just like stream line by line, so user can see the answer, and then it's reduce the latency. Improvement 6, structure JSON output. Structure JSON output is an important improvement because responses are returned in predefined machine readable format. Predefined outputs are necessary for allowing the generated information to be processed automatically by computer system in the subsequent step. Benefit of structure JSON output. Improve output consistency. The structure JSON for the fixed output. Also, it's provide easier downstream processing. Free-form text is difficult to pass reliably. JSON make downstream processing much easier, such as like web app or API. This is an example for structure JSON output. You can see like the response is JSON format, and it has like a answer field, citation field, misinformation, and confidence. Improvement 7, external vector databases. External vector databases are an important improvement because they provide scalable storage and retrieval for document embedding. Vector databases are designed specifically for semantic search, similarity retrieval, metadata filtering, and large-scale document management. So like I said, the benefit are like better scalability. Basic rack system use in memory, it become inefficient for thousands or millions of chunks. It provides faster retrieval. Vector databases use specialized indexing techniques such as approximate nearest neighbor search. This enable fast similarity search. Um, is also provide persistent storage, local NumPy enabling, uh, uh, local NumPy embedding temporary external vector databases persist data automatically. It also provide better metadata filtering. Vector databases support metadata filtering directly. Retrieval can combine semantic search and metadata filtering. This improves retrieval precision and document specific querying. This is an example how I use the external vector database. This one is QDrand, and the retrieval result they are similar to like a local NumPy. So this means work. Conclusion, this project developed an AI research assistant with retrieval augmented generation of RAG to improve information retrieval and question answering. Um, it used the baseline from the CSCI-E110 as a baseline and make an improvement um, to improve like retrieval accuracy, scalability, response reliability. The metadata filtering allow more target search, reranking improve relevance of retrieved chunks, citation, rendering increase transparency by adding sources. Structured JSON output return a machine readable response for downstream applications. Streaming response improve user experience. Lastly, Qdran provides scalable vector storage for large document collection. The results show that combining RAG with LLM can significantly improve response accuracy compared to the baseline AI system. By using RAG, the AI assistant produces more reliable and context-aware responses. This project highlights the potential for future enhancements such as hybrid search, advanced pre-ranking models, and agentic research assistant. This is the comparison table between the baseline model and the new model. In the new model, we have like PDF support, metadata filtering, citation, reranking, streaming, JSON output, and vector database. This is the rack system architecture diagram. In the baseline, we go from like a document to chunking, embedding, local NumPy, top-care retrieval, and then we get the LLM answer. In the improved system, we have PDF file, and then we go to chunking, metadata, embedding, QDRAN, look at the external vector database, and go to the metadata filtering, top-care retrieval, we do the re-ranking, do the citation rendering, and then JSON and streaming, and then get the LLM answer. This is the reference that we have that I use for reference like for the retrieval augmented generation, QDRAN, LangChain, like OpenAI embedding, and streaming response, PyPDF, Gradio, and RAG architecture. Yep, thank you for listening.